Hello friends. Today we are going to study stoichiometric point defects. The compounds in which the number of cation and anions are exactly in the same ratio as represented by their chemical formula are called stoichiometric compounds. The defects that do not disturb the ratio of cations and anions are called stoichiometric defects. Stoichiometric point defects are classified into four types: vacancy defect, self-interstitial defect, Schottky defect, and Frankel defect. Let us study each of them. First, vacancy defect. When some of the lattice sites are vacant, the crystal is said to have vacancy defect. This results in decrease in density of the substance. This defect can also be developed when the substance is heated. This is the diagram for vacancy defect. Second, self-interstitial defect. Interstitial sites in a crystal are the spaces or voids in between the particles at lattice point. When some particles of a crystalline elemental solid occupy interstitial sites in the crystal structure, it is called self-interstitial defect. Actually, this defect occurs in two ways. First, if an extra particle occupies an empty interstitial space in the crystal structure. This extra particle is same as those already present at the lattice point. Second, if a particle gets shifted from its original lattice point and occupies an interstitial space in the crystal. Here we can say that there is a combination of vacancy defect and self-interstitial defect. Here is the diagram for self-interstitial defect. Third, Schottky defect. If an ionic solid equal number of cation and anions are missing from their regular positions in the crystal lattice, creating vacancies, this type of defect is shown by highly ionic compounds which have high coordination number, small differences in the size of cations and anions. Few examples of ionic compounds exhibiting Schottky defect are sodium chloride, potassium chloride. Here is the diagram for Schottky defect. Fourth, Frankel defect. If an ion is missing from its regular lattice site, causing a vacancy or a hole, and occupies an interstitial site, electrical neutrality as well as stoichiometry of the compounds are maintained. This type of defect is called Frankel defect. Since cations are usually smaller, it is more common to find the cations occupying interstitial sites. This type of defect is present in ionic compounds which have low coordination number, large differences in size of cations and anions. Few examples of ionic compounds exhibiting Frankel defect are silver chloride, silver bromide. Here is the diagram for Frankel defect. Thank you.